and welcome to Health Economics Calculations Part 2. Today I have my trusty cameramen with me. You want to say hi, Jangi?
Hi!
Hi! You want to say hi, Khalil?
Hello!
Right, so today we're going to be covering NNH, number needed to treat, number needed to harm, cost of private prescriptions and QALYs. So without further ado, let's get into it. Khalil, you want to zoom in on the iPad?
Okay, sure, okay. Coming.
Wonderful. This is an example of a private prescription calculation question. In terms of variation for the exam, they may give you, for example, a set number of days over which supply has to be made. So you may need to calculate and times the value by the number of days of treatment. There could be variation in terms of the percentage markup, so different pharmacies have a different markup for their questions, for their prescriptions. So in this scenario it says cost of medicine plus 20%. They may give you a different percentage value. In this scenario, in this question, it talks about additional fees for CD items. So we have to take into account which item is a CD, which one it's not. They may give you a veterinary prescription, which may incur different fees. So it's really just about understanding what it is the question is asking for. So a good idea in this scenario would be to pause the video, have a read through the question, and then when you press play, we'll tackle this question together. The best methodology that I find with private prescriptions is to really lay out the format of your answer in the way the formula's been given to you. So for example, it says cost of the medicine, so cost of the medicine plus 20% plus a £4.50 dispensing fee per item plus a £4.50 CD fee. So I'm going to write here CD fee and I'm going to write here item fee, which will just make a little bit more sense. So if we start with the lactulose costs £2.50. We're going to add 20%. So how do you add 20%? Well, you times it by 1.2, or you could do plus 20% on your calculator. We're going to add £4.50 for our item fee, and we're not going to add the CD fee. Why? Because, well, hopefully at this point you're aware that lactulose is not a CD. Let's move on to our second one, which is oxycodone 40mg MR tablets. Now, this question is really quite straightforward because what they've done here is they've told us that it's 56 at a cost price of this, 300 mils at a cost price of £2.50. If the question had told us that lactulose cost, I don't know, let's say £4 for 500 mil, and we've supplied 300 mil, then obviously you may need to calculate out the quantity of supply for that price. If oxycodone, let's say for example, came in a pack of 56 and we were only giving 28 out, you would have to calculate the supply. But in this scenario, it's pretty straightforward. So let's carry on. Oxycodone 40mg MR is £37, so £37 times 1.2, which is my 20%, plus my £4.50 item fee. And in this scenario, I'm going to add £4.50 for my CD fee. Now taking a look at oxycodone liquid 250ml, it said it cost £6.70. So £6.70 times my 1.2 for my 20% plus my £4.50 for the item fee, and I'm going to add a £4.50 here for the CD fee. Now calculating those answers, it gives me a cost of lactulose at £7.50. For the oxycodone 40mg MR tablets, it's £53.40, and for the oxycodone liquid, it's a cost of £17.04. Now, adding all these values together gives me a grand total of £77.94. Now, looking back at my question, it says, use this formula to calculate the price of the prescription, give your answer to the nearest penny. So £77.94 is rounded to the nearest penny. A good exercise would be, after you answer your question, always read the last two lines in the question again, just to make sure that you've given it in the correct format to the correct number of places that they're asking for. This is an example of one of the number needed to treat health economic questions. There are a few different ways in which number needed to treat questions can be asked, so I'm going to try and provide you with a few different examples of these. Please be aware again that the methodology that I'm going to use is a methodology of how I teach my pre-regs and one which I am comfortable with. There are many different ways to do these questions. So if you find another method which is perhaps less steps but more convenient for you, then obviously stick with whichever method you are most comfortable. The idea behind the way in which I tackle these NNT questions is that if in the exam they change the question to be of a much more wordier format, or they provide a lot of superfluous information, you can essentially just extract out the key information which you need and apply the same methodology to get to your answer. A good idea at this point would be to pause the video and read through the question, after which when you play the video we can tackle this question together. Now, the first thing which is always advisable in the exam is once you've read through the question, is to highlight out the key parts which are important to you. I always advise my students to jump to the end of the question after reading through it once and pick out the key bits of information that are going to be really important. So at the bottom here, what I'm going to do is I'm going to highlight the fact that it's asking what is the number needed to treat, and also that the question's asking for the answer to the nearest whole number. Now, one thing I will mention is that whenever you're dealing with number needed to treat, the answer is always given as a whole number because it's referring to the number of patients that are needed to treat. So we would never give the answer in a decimal because obviously you can't get half a patient or a decimal of a patient. So when you calculate your answer, you always need to round the answer up. Now, this is the only scenario in pharmacy calculations where we would automatically, regardless of what the decimal number is, we would round the answer up, which I'll come back to at the end. So now that we know we're dealing with a number needed to treat question and they're asking us to calculate the number needed to treat, the way I always tackle these questions is to use a two-stage process. So here on the right, you can see that there are two equations. The first equation in the red box here relates that the number needed to treat equals 1 over the absolute risk reduction. For the time being, just follow me here with regards to the formula. So the second stage of the process is talking about what is absolute risk reduction and how do we calculate this. So absolute risk reduction, which is the bottom half of this fraction over here, 1 divided by absolute risk reduction. So absolute risk reduction equals the event rate in the control group minus the event rate in the treatment group. Don't worry too much about this at the moment. The best way to tackle these questions is to just follow the methodology of this process, which is that the absolute risk reduction, really what it means is the number of outcomes divided by the total number of people taking part. That's one part of the equation. Take away, again, the number of outcomes divided by the number of people taking part. This will make a lot more sense once we tackle this question. Now, looking at the question over here on our left, it mentions that 491, sorry, I'm just going to change the colour of this. Here we go. That 491 patients out of 1,227 took the ibuprofen 800 milligram. And they've given us a percentage here of that to say that that's 40% of the patients. They've then said that with placebo, 321 patients out of 1,118 took the placebo. And again, they've given us a percentage value for that, 29%. Now, sometimes when it asks you for an answer for NNT in exam questions, they may automatically have calculated this value as a percentage for you. In some scenarios, they may not have calculated this value as a percentage for you. They may just give you here, like for example, the number of people that took part in the study and the number of people that had an effect via either placebo or by the drug, and you will therefore have to use this equation to calculate your answer. Now, I know that some people can actually just use the percentages and do this in a quicker method, but the methodology I always use is to just calculate this equation and ignore the percentages if they've given us the numbers here. So let's tackle this and it'll make a bit more sense to you. So here we go. So the first step that we're going to do is we're going to lay it out in order. So we're going to start with our ibuprofen here, which was 491 patients took it out of a possible 1,227. So I'm going to calculate the first step, which is the absolute risk reduction. So I know that over here, that 491 divided by 1,227 equals, and just to make it a little bit easier for you guys, I'm going to use a different colour just to circle this to show you what I'm actually doing here, guys. And at the same time, what I'm going to do over here is I'm going to do 321 divided by 1,118, and this value here, 321, is taken from here. So 321 is my number of outcomes, 1,118 is my total number taking part. So I'm going to get a different colour here just to show you. There you go. So 491 divided by 1,227 is the number of outcomes divided by the total number of people taking part. That gives me an answer of 0.40, and 321 divided by 1,118, so 321 people here took the placebo, and the total number taking part is 1,118, and that gives me an answer of 0.287. And as you can see, although they gave us the percentages 40%, and we could have just converted that to 0.4 here, and they gave us a percentage of 29%, and we could have converted that to 0.29 here, because 0.287 rounded to 2 decimal places is 0.29. However, it's better to always calculate it if they've given you them as numbers using this equation. The reason being because sometimes they don't give you the percentage, and if you stick to doing the same methodology of this step every time, you won't go wrong. You'll always be in a position whereby if they've given you less information, you can still calculate the answer correctly. So now that I've got my two values, what I'm going to do here is I'm going to work out the absolute risk reduction. So ARR equals 0.4 take away 0.287. So again, ARR equals this value here, 0.4, subtract 0.287, which gives us a value of 0.113. Now that we've calculated the absolute risk reduction, we can take a look at our two-stage process up here. So the first stage is to calculate the ARR. The second stage is now to calculate the red box here, the NNT. So what we do is we do 1 divided by the ARR. So if we scroll down now, and what we say is that the top box in red told us that 1 divided by the ARR equals an NNT value. So 1 divided by 0.113 will give us our NNT, which is equal to 8.84. Now remember that the answer said that it wants the NNT number needed to treat, and earlier I talked about we can't give an answer in decimal places because the number needed to treat is the number of individuals, so we round this value up to 9. So whenever you're dealing with NNT, it's the only situation in pharmacy calculations where regardless of what the decimal place is, so I'm just going to highlight this to show you, regardless of what this number is going to be in a decimal place, you're going to round it up to give you 9 in this scenario. So for NNT, we always round up. This is another example of an NNT question. Again, it would be a good idea for you to pause the video and to have a read through the question. I'm just going to dive right into it, and we're just going to use exactly the same methodology that you've just learned from the previous example, and I'm going to show you how this can be applied in this scenario. So again, after reading through the question once, what do? We go to the bottom of the question and we highlight out what is the question actually asking us, what is the key piece of information it wants. So it wants the number needed to treat, and it wants the answer to the nearest whole number. And remember, regardless of if they ask for the answer to the nearest whole number or not, NNT is a scenario where we always round our answer up to the nearest whole number. So now I'm going to take my two-stage process from up here. We've got the red box, which tells us that the NNT is 1 over the absolute risk reduction, and we've got the orange box, which is telling us how to calculate the absolute risk reduction. So whenever you see this question and it asks you to calculate the NNT, the number needed to treat, the first step we're going to do is we're going to calculate the absolute risk reduction, which is the orange box. So in the table on the left, we can see the total number of participants that took part in each group, 1500, so an equal number in each group, and we can see how many were the number of outcomes for each group. So for treatment A, there were 510 outcomes, and for the control group, there were 620 outcomes. Try and use the same layout for each NNT question from example 1. That way you're consistent with your way of working. So what I'm going to do here is I'm going to do 510 divided by 1500 equals, and I'm going to do 620 divided by 1500 equals. So let's just have a look at where these values have come from briefly again. So if you look on the left here, you can see that the number of outcomes is 510. You can see my number of participants is 1500. So using this formula here, number of outcomes divided by total number taking part, 620 divided by 1500 there, and it's the primary outcomes over the total number of participants. So working those out, let's fill in our answers. So 510 divided by 1500 is 0.34, 620 divided by 1500, 0.3333. Now we can calculate the absolute risk reduction by subtracting 0.4133 minus 0.34. So ARR equals 0.413333 minus 0.34, which gives us an answer of 0.073333. Just remember that when you are doing these calculations, do not make the mistake of rounding up at any point or rounding down here at any point. Use their values exactly as they are right until the very end. There's very few scenarios in calculations where midpoint during a calculation you would ever need to round up or round down. It's normally always done at the end of a question. There are a few exceptions to the rule when it comes to quantity to supply type questions, but we'll deal with that in another video. So now that we've calculated the absolute risk reduction, what we do now is we take our formula in the red box up here where NNT equals 1 over ARR, the absolute risk reduction, and we just do 1. I'm going to write this out again just so that you can see this and understand what it is I'm doing. So 1 over the ARR, so 1 divided by 0.07333, which was taken from here, gives me an answer of 13.636 and so forth. Now this is my NNT, and as you can see up here I made a bit of an error. I wrote NTT, getting carried away there. Let's just correct that. There we go. So now that we know our NNT is 13.636, remember we always round this up because obviously we're referring to people, individuals, the number of people needed to treat, and we can't have a decimal person, so the NNT would equal 14, because we take this number here and we just round it up to give us 14. Now this is another example of a number needed to treat question. I've deliberately put this one in here to show you a different format of an NNT question. So as opposed to it giving you, for example, two different types of treatment, i.e. drug A and placebo, and then values for each one, all they've given us in this question is a percentage. So if you want to pause the video and read the question through before you see how I tackle this, that would be a good idea. But essentially, again, all I'm going to do is I'm going to look at the question, I'm going to look at what it's asking for. I've highlighted the fact that, look, it's a number needed to treat question. How many people need to be treated? That's what the question is, an NNT question. So when I see that question that it wants an NNT, straight away I'm going to be thinking, right, I'm going to lay it out in the same format as my previous two examples, and all I'm going to do is I'm going to take a look at the question, and I'm going to see that it says that it's a 5% risk of stroke compared to placebo. So if it's 5%, again, I'm going to calculate the absolute risk reduction first in the orange box, the ARR. So I'm going to do 5%. And what does 5% mean? 5% means 5 out of 100. So you do need to know this, guys, that whenever you get a percent, it means out of 100. So therefore it's 5 outcomes divided by 100 people taking part. So look at the formula here. ARR equals my number of outcomes divided by the total number of people taking part. Forget this part here where it says minus something for now. Just look at this number of outcomes over the total number of people taking part, and that's what the question's telling us, that there's 5%. So 5 over 100, which is equal to 0.05. So that's my absolute risk reduction. The next step is I'm going to take the red box, the NNT equals 1 over ARR. So NNT equals 1 over ARR, which would be 1 over this value here, 0.05, which gives us an answer of 20. Therefore, the NNT is 20. 20 patients need to be treated with drug A to prevent one stroke. There's no rounding up needed. So again, I've used the same layout, I've used the same format, because the question was asking for me to calculate the NNT. It's asking for me to calculate the number needed to treat. So what am I going to do? I'm going to calculate my ARR from the orange box, the absolute risk reduction. And then I'm going to calculate the NNT by doing 1 divided by that answer. Right, so this is an example of a number needed to harm question. Number needed to harm, essentially the methodology that we're going to use to tackle this question is exactly the same as the number needed to treat question. Okay, so first thing, number needed to treat and number needed to harm are two different things. Number needed to treat is the number of people we need to treat to get one positive outcome. Number needed to harm, on the other hand, means the number of people that we need to treat before we get an adverse event. So before something goes wrong. But essentially the methodology is exactly the same. So if we look at the formula that we were using for number needed to treat, we can just use the same formula and the same method again. It doesn't really make a difference. It's easier to learn when tackling exam questions, a certain format, a certain way of working. So if you wanted, okay, I could, look at the formula here in the red box, and I could delete this T here and replace this with a H to say number needed to harm. I could delete the bottom bit where it says absolute risk reduction and rename this to say absolute increase in adverse events. So delete this bit here if I wanted to say absolute increase in adverse events. But guys, it's just the same thing again. So let's tackle the question. If I'd advise you to pause the video, read the question. Once you've done that, you'll come to realise that at the bottom here, what is the question actually asking us to calculate? Well, the question's actually asking us to calculate the number that is needed to harm. So calculate the number that's needed to harm. So what are we going to do? We're just going to do the same thing again. We're going to say, okay, in the question it tells us that sorry about that. Let's try that again. It's telling us that 8.8% of patients receiving the new drug experienced an adverse effect compared to 3.8% in the group who received standard treatment. So therefore, lo and behold, we're going to say number of outcomes is 8.8, and we're going to divide that by the total number of people taking part, which is 100. How did I know that? Remember, look, 8.8%. Percent means out of 100, so 8.8 out of 100. Therefore, I knew that. And again, I'm going to take 3.8 and I'm going to divide that by 100. And I'm going to work out, so 8.8% means 8.8 out of 100. 3.8% means 3.8 out of 100. So 8.8 divided by 100 is 0.088. 3.8 divided by 100 is 0.038. So when we had number needed to treat, we were calculating the absolute risk reduction. What we're doing here really is we're just doing exactly the same thing again, and instead of calling it absolute risk reduction, what are we calling it? We're calling it the absolute increase in adverse events. But again, for the exam, just learn the methodology and the way of working so that you know what it is that you're doing. So if I do now 0.088 subtract 0.038, that will give me an answer of 0.05. And the second stage of my process is I'm going to calculate the number needed to harm, which is 1 divided by this answer. So 1 divided by 0.05 gives me an answer of 20, which is the number needed to harm. So essentially, number needed to harm, we do the same methodology as before, like for number needed to treat, and we get our answer. The difference is we're looking at the number of people that are needed to be treated before there's an adverse event versus the number of people that need to be treated before there's a positive outcome with number needed to treat. Another important point to note is that with number needed to harm, if we get a decimal place answer, then we would round down in this scenario. Now, this is very important, and there is a lot of information and literature out there explaining why with number needed to harm we tend to round down, and when we're dealing with number needed to treat we round up. It's just something that you're going to have to learn. Should this question turn up, then you should be aware that it's important that if you get a decimal answer, round it down to a whole number. If you get a number needed to treat question and it's a decimal answer, round it up. This type of question is another health economics question. However, this time it's looking at QALYs. What are QALYs? QALYs are quality adjusted life years. So essentially, it's a health economics question which you may actually use in practice if you were working as a practice pharmacist and you came across drug expenditure or a new type of drug treatment that was coming to the market and you wanted to assess whether it would be of benefit to be prescribed in the community on a cost basis. So a quality adjusted life year, essentially one QALY, what it means is a patient has 1 year in good health. So if a patient has 0 QALYs, ultimately they're dead. They've got no adjusted life years. If a patient has 1 QALY, then that means they've got 1 predicted year of perfect health or good health. So a QALY really takes into account, you could say, the effect of a treatment on a patient's quantity and quality of life. Now, what do you need to know about QALYs? So first of all, if we look at this question, it would be a good idea for you to pause it, have a read through it, and then I will tell you how I would go about tackling this. Now, hopefully, if you've watched my other videos and you've seen the other examples of the other health economic type questions, you'll have come to grasp that I try and learn and use one type of methodology for each type of question that may be encountered. So I'm going to scroll down here. I'm going to bring up 2 formulas or equations which I tend to come across being used for QALY questions. So in the orange box is the first one. How do we actually calculate a QALY? So a QALY is calculated by multiplying the estimated survival time times the quality of life. So for example, if we knew that a patient was going to gain so many years of extra life from a drug treatment and their quality of life was going to be a certain number, we could multiply them 2 together to get our QALY. Now, sometimes the question may ask you to calculate the cost per QALY of a new treatment that's been gained. So that's where the second formula comes into play in the red box, which is cost per QALY gained. So that would be the difference in the cost financially, so that would be in pounds, divided by the difference in QALYs. And the QALY we would have calculated by using this orange box formula. So as you can see here, this would be a 2-step process, a 2-stage question. So if you've paused it and you've played it, let's begin. So the first step we're going to do is, from our question, we're going to look at with treatment and we're going to calculate the QALY. So we know that the estimated survival time is 8 years. So it would be 8 times the quality of life, which is 0.75. Now, be aware that there can be variations in questions. So where can variations occur? Well, this estimated quality of life may be given to you as a percentage. If this is given to you as a percentage, you would have to convert it to a numerical value. So 0.75 would, if for example they had told us that the estimated quality of life is 75%, we would have converted this to 0.75. But in this example, it's been given to us. Now going on to the second one, without treatment, if I'm going to calculate the QALYs here, it would be 5 times 0.45, as it's 5 years times by the quality of life, which is 0.45. Now 8 times 0.75 is 6.0, and 5 times 0.45 is 2.25, and these are QALYs. So I'm just going to write this here so it makes sense. Now moving on to the second stage of the question, we can take our red formula here, which is difference in cost divided by difference in QALYs. Well, in the question it tells us here that the cost per treatment is £15,000 with treatment, and without treatment there's no cost incurred. So you can see there 15,000 take away 0 would be 15,000. So 15,000 is our difference in cost from this formula here. I'm just going to draw an arrow if it helps you. And the difference in QALYs, well, the difference in QALYs is going to be 6.0 minus 2.25, because that's taken from here. We worked out the QALY with treatment and the QALY without treatment, and that gives us 15,000 divided by 3.75 equals, and that gives us an answer of £4,000. So we have now calculated what the cost is per QALY. So again, to summarise, let's have another look at this. What did we do? We first of all calculated what a QALY was, and that's the estimated survival time times the quality of life. So 8 times 0.75 if we look on the left here, and 5 times 0.45. Once we'd calculated our QALYs, we then took our second formula, which was the difference in cost divided by the difference in QALYs, which is 15,000 was our cost, and our difference in QALYs was 6 take away 2.25, which gave us 15,000 divided by 3.75, which is 4,000 QALYs. Right, so this is another example of a QALY health economics question. This is example 2 for QALYs. So what I'm going to do is I'm just going to dive right into it. My advice to you is pause the video, have a read through the question. Once you've read through it once, highlight out what are the key points in the question at the end. So again, if you look at the last line, hopefully you've paused it and now you're going to press play. It says, what is the cost per QALY gained for drug B? So I would highlight this bit yellow, and to the nearest pound I would highlight this bit yellow. So I've highlighted my 2 key pieces of information that I'll double check at the end of the question. Now I'm going to scroll down. There's my formulas that we used in the last example. A QALY equals estimated survival time times quality of life. My second part of the formula is cost per QALY gained equals difference in cost, which would be in pounds, divided by the difference in QALYs. So what I'm going to do, I'm just going to dive right into this now, and I'm going to calculate the QALYs. So to calculate QALYs, I'm going to take 8 years and I'm going to multiply this by 60% of quality of life. Now remember, 60% quality of life here, we have to convert to a numerical value. So to convert 60% means 60 in 100, which is 0.6. So 8 times 0.6 will give me the QALYs for her normal life if she continues with drug A, essentially. So 8 times 0.6 gives us 4.8. So 4.8. Now taking a look at medicine B here. Drug B has just been marketed for the same condition. If Mrs. Preston were to switch to drug B, she would live for 11 years with a quality of life of 75%. So 11 years times by 75%. And remember, we can't do 11 times 75%. We're going to convert that 75% to 0.75, a numerical value. 75% equals 75 in 100, which is 0.75. 11 times 0.75 is 8.25, and that there, folks, are our QALYs. So I'm just going to write here so we know QALYs. Right, okay, so now that we've calculated that, we can now move on to the second step, which is the red box, cost per QALY gained, which would be the difference in the cost divided by the difference in the QALYs. So what's the difference in the cost? Well, in the question it says it would cost £12,000 more to treat Mrs. Preston with drug B. So £12,000 more, they've already told us the difference in the cost. We don't need to calculate that part, it's 12,000. Had they said treatment A cost £1,000 and treatment B cost £12,000, we would have done 12,000 minus 1,000 to give us 11,000. But in this question it says it would cost £12,000 more. So now that we've got our value of £12,000, we can put that in the top of the formula, difference in cost. Now we need our difference in QALYs, which would be 8.25 minus 4.8. Where did we get that from? Well, over here we calculated what each QALY was for treatment A and B, and now we just subtract them to get the difference. So 8.25 minus 4.8 gives us 3.45. So 12,000 divided by 3.45 gives us an answer, £3,478 and 26 pence. Our question asks for an answer to the nearest pound, so 26 pence would be rounded down, giving us £3,478, which is the cost per QALY gained.